All right, welcome back to the channel. In this video, or in this series of videos, we've been talking about reading and writing data. So far we've been reading data from CSV and JSON files. Up next, we're going to talk about JavaScript. So we're going to actually write some data to JavaScript. We're also going to actually write some data to a text file as well, and part of our test, because in this video, we're going to be testing or comparing using building a string using a StringBuilder, which is string concatenation, versus using string addition. So in string addition, what you might be either doing or might have seen a lot of, in a lot of code is where you just use plus equals to add on to your string. And so in this video, we're just going to kind of go into that a little bit, and we're actually in the program we're going to test that with like different size loops and that sort of thing. So so this set of videos, again, we're talking about JavaScript files or .js, and so depending on how long it takes to go through this, it may or may not be split up into two videos. But the first part, we're going to write some data. We're just going to loop through a structure set, like a dummy structure set. And depending on how many, whatever size that we determine the loop should be, we will continue to write the structure data to the file. And so if we do 100 loops, it'll be larger than if we just did, the file size will be larger than if we just did one loop, obviously. So that's just kind of the idea, so that we can test like how long it takes for string addition versus string concatenation. And then in the second part, we're actually going to show an example of how you can use HTML to load a JavaScript file and then view that data in a web browser. So and all of that, we'll do all of that without using a web server. So you won't, it's completely like static HTML file, that sort of thing. So with that, let's go to the project. And so just really quickly, let's show a sample a JSON file. And we'll remember that an object is denoted by this curly bracket, and then we have keys and we have values. Our keys and values can be, our keys are always going to be a string and a JSON file. So then our values can be, we can have strings, numbers, booleans, we can have null, we can have an array that's denoted by, let's see, actually I guess none of these, let me show this one. So we could have an array, so like in this beams property, we have an array of beams, and so each item in this array is a beam object, right? And then you can also have another object. So for example, this machine parameters object or property, its value is another object, and that object is called a machine parameters object, right? And then inside this object you have other properties. And then you can also have a boolean like true, false, that sort of thing. So a JSON file stands for JavaScript object notation. So in the first two letters are JavaScript, right? They stand for JavaScript. So the reason I'm kind of showing that is that you can essentially expect that to be what your JavaScript file object, the variable, whatever the variable is that you're defining in your JavaScript file, the object would look similar to that, right? So let's see. Let me show that really quickly. So in a JSON file, there's not a way to write comments, and there's not a way to define variables, right? It's literally it just contains data, okay? Whereas a JavaScript file, let's just open up one that we've written in tests. So let me just show you just really quickly. I'll do this one. I'll uncomment this and hit start. And essentially what we're going to do is we're going to tell it how many loops we want to loop through. And so let's just do one, right? and then it's going to test everything. So to do one loop, it took 0.002 seconds. Using string addition, it took 0.001 seconds to use the StringBuilder or concatenation. And then with logging, it took 0.005 seconds to use string addition, but some of that extra time, so it took 0.003 extra seconds to do it this way because we were also logging, right? And then down here is the summary. But one of the outputs is a JavaScript file. And let me open this with, I will open it with Visual Studio Code, which is a lightweight editor, IDE. But it has a lot of really cool features. So if you're using Visual Studio for your C# projects, obviously you want to build those, and you can do that in here, but it just takes some extra legwork. It's a lot easier for me to do it in Visual Studio. But if you're doing like a Visual Studio Code is just a good text editor to accompany Visual Studio. It's just nice. It just has a lot of nice features, and it's lightweight. So if we look at this file, so I was able to format it, and so we can see that we're defining a variable. We're saying let this variable name, so string addition data. So this variable was made via string addition. Then there's a separate file. I'll just go ahead and open that as well. And let me format it. And this one is StringBuilder data. So obviously this was made using a StringBuilder. So we just have an array of structured data. And then we also have, in each of the files, they're formatted the same. They're written exactly the same. Both of the files look identical. The only difference is the time elapsed, and the number of loops will be the same as well. So in each of the files, it will always have the same number of loops. It will always have the same structured data. The only difference will be the time elapsed. So this elapsed object, and then there's elapsed.seconds and milliseconds. And so we have the same data in the string that was made from string addition. The only difference being that the time is longer. It took longer here, right? And again, this was to loop through the structure set one time. So this is an example of what a JavaScript file might look like. However, in a JavaScript file, you could actually add a comment. So if we wanted to, whoops, it's actually the same as a C#. So 2 forward slashes, and then this is a comment. So you can actually add that, right? You can also add functions, right? So you could, let's see, I can't actually remember if that's how you define a JavaScript function, but let's say test. I don't think that's it. No, I don't think that's it. Oh, you know what it is? It's function. Yeah, that's it. So you denote a function with function. So then you could pass in whatever parameters. With JavaScript, you actually don't have to tell it what it is. It'll just figure out what it is based on what you do with it in the thing. So like in in C#, you have to say like string, whatever, ID, right? And that would be your variable. But here you actually just say ID. And then down here you use it if ID equals whatever. Then do this. Right? And then you could do these different things. I'm going to get rid of that though because that's not what we need. So that's just an example of using JavaScript. Or like a JavaScript file. So let's just shrink this down. So let's go over the project just really quickly. So similar to the other videos, we just have this JavaScript model. So it's a separate model that contains the methods that we want to use that. So we have a method that will save using string addition, and then a method that will save using StringBuilder. If we go into these methods, so we have both of these methods are going to use a similar method to this. So we're going to get structured data using string addition. And then we're going to, let's see, that says get. And then this one says append string data to StringBuilder. So instead of string addition, where we use plus equals here, we're going to just append it here. But it's basically going to be the same method, right? So I guess probably what would have been smarter would have just been to append it here, and then have this method actually just return the string value. That would have been smarter, because I know I would have only needed one, because you can see they both do basically the same thing. And then in this method here where we save it with a string, instead of running the method, we would actually just say plus equals this, right? And then we wouldn't even have to pass it this. That would have been smarter, but alas, I didn't do that. And now I require two methods. So anyway, we'll just go with it as it is. But feel free to make that improvement as you see fit. So one of the things I wanted to go over, and what we'll talk about a little bit more as we see like how long it takes. If you noticed, it took a little bit longer to do the string addition, even though it was like, you know, a fraction of a second, right? But imagine you're doing that 1,000,000 times or 100,000 times or 1,000 times, right? It gets progressively longer and longer each time. So the reason for that is because string data types are immutable. What that means, they cannot be edited. Whereas StringBuilder objects are mutable, which means they can be edited. So if you notice with the StringBuilder, we actually are appending something to it. And what happens is just, I'm guessing it's just a list, right? Let's actually look at it and see what it says. So a StringBuilder object, let's just go to it and see if there's, so there's an append. So it's a character array, chunks. So I guess it's just appending those characters to the character array. I expected it to be a string array, but I guess it's just a character. It doesn't matter. I could be completely misinterpreting it. But basically, we're just appending to it every time. Whereas with strings, because they're, let's see, where did it go? Because string data types are immutable, that means that they can't be edited. Which means that every single time we want to change what that string value is, that same string value, we actually have to recreate it. And so we have to create that new string in memory as well. So we're committing it to memory. So you might see the memory spike. And if you're not doing it in like a loop or whatever, maybe it doesn't even get disposed. Maybe it's just currently, you know, it's just staying in memory. Every single time, so you can imagine, like if we're looping through 1,000 times, every single time we loop through, we're generating a new string object, as opposed to just editing the existing string. And so, and not only that, but as the string gets longer, we have the original string in memory, but we're also creating a new string in memory, and it's, you know, both, as they both get longer, they just get longer and longer, and it just continues to take up more and more memory, right? So that's the reason that you might choose to use a string builder over just simple string addition. So essentially, that's what these do. There's an extra method that, or in the save data with string, so string addition, that's really what it should be named. There's a couple of extra properties, or parameters rather. So path to log the progress to, and the whether or not, a Boolean of whether or not we should log the progress. So when this is false, these are the defaults. So when this is false, we don't need this. But when this is true, then we need a path, and so we're going to pass it the path of, let's see, so a string addition, we're going to pass. So the first time we do it, we're not going to log, we're just going to do the work. But the second time, after we do that, we're going to test why the string addition takes longer. And so we're going to give it a path to log the data to, and we're going to save it to log.progressFile.loopsize.txt. So this is an example of how you might log to use a text file to log a whatever data that you want. So with that, let's just go ahead and run it a few times, and then we'll check out those logs to see like why it takes longer. So let's do it 100 times. And actually I didn't bring it over, so I'll just close that. Let's do it again. So let's make this bigger. Let's do it 100 times. And so you can see that it took 13 seconds, 0.13 seconds to use string addition versus 0.07 seconds to use a string builder. And then obviously it took a little bit longer, even still, when you log it. So if we open that log file, what did we do that 100 times? So all this log file it's telling us which loop it's on, how many characters the string is, and how many seconds it took to generate to add on to that string. So if we go, so at the top we're in 8 times 10 to the negative 6th, so like 5 zeros. Whereas down here we're only to 4 zeros. So as you can see, each progressive time, and if I go here, let me show you what it's actually looping through. So let me stop it. And in the JavaScript model, what it's doing is it's actually looping through, it's logging the time it takes to add each additional structure. So it's looping through, so each iteration, however many loops, it's actually looping through the structure set. Again, this is just like dummy data. It's looping through each structure in the structure set and logging the time that it takes to add on the data for each individual structure. So it's not just how long each loop takes or each iteration takes, it's how long each individual structure takes. So that's why there's like 10 lines for each iteration. So like in our text file we saw, we see like loop 99, right? This is the 100th iteration. There's 10 of them. So if we count that, that's probably 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, because I think there's like 10 structures in the structure set. And so we can see that, for this subset, they're all like pretty close, right? But when we go from the start to the finish, it's an extra 0 in there. And again, that's 100. So if you're doing this for ESAPI, like you probably don't care, right? But if you're doing this a million times, or if you have this huge spreadsheet that you're trying to process, maybe you want to use or trying to write or whatever, maybe you want to use StringBuilder instead. So let's run it again, and instead this time let's do 1,000. So sorry, I didn't make that any bigger. So you can see it's taking a little bit longer this time. So it still only took 4.7 seconds, but it took literally a half a second to do it with a string builder, right? And then when we logged, it took an extra 3.1 seconds or so. So let's just try it let's try like 5,000. And I think in this case, I'm probably going to have to pause the video. But let's do 5,000. And I will pause it because, so you can see it's kind of like, it's moving through there pretty quickly. It got to 25% pretty quick. But here in like now, you're starting to notice like it's slowing down there. And so each progressive time, as the string gets bigger and bigger and bigger and bigger and bigger, like it's committing more to memory. So you can see like you can see in the memory, it's kind of going up, and it's spiking and going up, down and spiking. And it's even increasing, right? So it was in the 180s, now it's almost to 200. I think it's eventually going to get up to like 280 or something like that. So you can just see like the memory that is required to do this. So anyway, I will pause it, and once it's finished, then I'll pick it back up. All right, so we're up to 98%, and it's taken quite a while. You can see how long it's taken to go through each one. But look at how fast. I wanted to unpause it right before the end of that so that you could see how fast it would be for the string builder. It literally took 177 seconds, so almost 3 minutes to use without logging to do string addition, right? But it literally only took 2.5 seconds to do the same data, to collect the same data using a string builder. I mean, that's just nuts, right? So this is going to run through again, and I can show you the data. Let's see. Let's see. We actually already have those files open. So here now you can see, like, I won't format this because it could take a while, but you can just see like this is looped. The structure set rewritten, like the information from the structure set rewritten 5,000 times, right? And you can see it took, oh, this is the string builder. So you can see it only took 2.5 seconds. And as opposed to with string addition, you can see it's the same exact file, but it took 177 seconds, right? Which is exactly what the thing printed out. But you can just see like that's a lot of data, right? But you can imagine if you start collecting data and then you're creating these JavaScript, maybe you're appending to it every single time you do a plan or something like that, then you can imagine it would grow, pretty large. And then once it gets to a certain size, you'd probably want to start a new file or however you want to do it. Doesn't matter. I don't care about that. But you can see it's still, with logging, it's still at 77%. And so let's look at, while that's still working, let's look at the difference. So we looked at 100 times. Let's look at the log that was generated from 1,000 times. So this is 1,000 loops. So if at the start we're still at 1 times 10 to the negative fifth, or 8 times 10 to the negative sixth. So again, like times 10 to the negative fifth, that's with 4 zeros. That should be with 5 zeros when it's to the negative sixth. And let me actually make this wider. I made it too big. So at the bottom, let's see, where are we at? So at the very bottom, we're down to 2 zeros. So we started at 4 or 5 zeros. And now we're at the bottom, it's taking each structure, it's taking down to, either 3 or 2, even 2 zeros, depending on, whatever's going on. So you can see like 3 zeros, I think it's like around the 2,000 mark. So around the 1,000 mark, what loop is that? Oh, this was only 1,000, I'm sorry. So this was only 1,000 loops. So yeah, so even after 1,000, so once we get to 1,000, we're down to the 2 or 3 zero mark. And then let's take a look. The 5,000 just finished, so let's take a look at that file. Oops. Okay, so to start, again, we're at the times 10 to the negative fifth or sixth. And then around the 1,000 mark, we're at, again, 2 zeros, 2 or 3, because even after that, we're still seeing some in 3 zeros. And again, this is total seconds. And then once we get down to the bottom, we're seeing pretty consistently 2 zeros, right? So it's still not even taking that really. it doesn't really get that much slower to a point. Like once you get to a point, it doesn't seem to really get, oh, here's one with 1 0. So maybe it is. And to be honest with you, I have a pretty fast computer, so you know, if you're on a machine that's not very powerful, it might even take, you know, way longer. I don't know. You'd have to test it. But anyway, so that's just an example for that. And then I think, you know, to be honest with you, we're actually only at 25. Well, we'll stop it. So we'll stop this video. And in the next video, what we'll do is we'll show an example of how you can load a data file into an HTML document. So, all right, with that, thank you for joining, and I'll see you in the next one.